Jelle, Rebecca, and Carl. Welcome to all of you type-loving Pythonistas. Awesome to have you here on the show. Thanks for being here. We're going to talk Python typing, especially from the perspective of the Python Typing Council, which honestly, I am a huge fan of Python typing. It's still something I learned about not too long ago. So I'm going to be learning along with everyone else what it is you all do and so on. So I'm really excited to be diving into this. I think since types came to Python, I think it's made it a little bit more rigorous, for all those people out there like, oh, it's not a real language without any form of static typing. We can't use it on real projects. I don't know how true that was, but certainly it's less true now. You can pick per project. So it's super cool. Before we get into all that, though, let's just go around for quick introductions. Jelle, welcome to the show. Awesome to have you here.
Hi, yeah. I'm Jelle. I've been on the Python Typing Council since the beginning. I helped set it up a couple years ago. Outside of my typing work, I currently work at OpenAI, where I work on developer productivity, which means things like running CI for people and generally helping people be productive. I've been working with Python for more than a decade. Started out because my previous job was mostly in Python, and then got more and more involved with the language.
Awesome. So let me get this right. At OpenAI, you're basically helping developers there have better developer tooling and common packages and workflows and stuff like that. Is that kind
That's
of the
right.
story?
Yeah. Mostly around things that happen in CI, like running tests efficiently, figuring out the right tests to run, getting the right CI workers up.
Yeah, that sounds very exciting. Right in the epicenter of all the big tech stuff these days. Super cool.
Yeah.
Rebecca, hello, welcome.
Hey, thanks for having me. I'm Rebecca. I've been on the Typing Council also for about 3 years, I think, less than 3 years, since the beginning. But my day job, I work at Meta on Python typing, on Firefly, which is a new type checker and language server written in Rust, still in beta. Prior to that, I was at Google for 8 years, also on the Python team. I really like Python.
Awesome. Yeah, super neat. I'm a big fan of both Firefly and TY, which will both have representatives here, I know. And I think it's just a super exciting time for Python types, and certainly that's one of the reasons. So very cool. Carl, welcome back.
Thank you. Great to be here. Yeah, Carl Meyer. I currently work at Astral, where I work on TY, which is a Python type checker and language server written in Rust, also in beta. And yeah, I guess how did I get into typing? Or I've been on the Typing Council not since the beginning. I think it's been a year and a half. And yeah, I got into Python typing at the time in 2016, 2017. I was working at Instagram, and that was in the very early days of Python typing. The PEP 484, PEP 483, the early Python typing PEPs had recently come out within the last couple of years. And one of the co-authors of some of those PEPs, Łukasz Langa, was actually sitting at a desk right next to me at the time.
Okay.
So, and at some point, we started to think that we should try this Python typing stuff on the Instagram server monolith. And so I took that on as a side project, and then it eventually became the main project, and then it took like 3 years. So a lot of Python typing experience there.
Oh, there absolutely is. I think a couple of things I'd like to touch on there. First of all, Instagram is is it maybe the biggest Django deployment in the world? It's certainly one of the bigger ones, right? And I think a lot of people don't necessarily know that a core chunk of Instagram is actually Python, right?
I don't know if we have any way to know how big the Django deployments in the wild might be, but it's certainly a big one.
Yeah, it's definitely a big one. There was some talks about dismissing the garbage collector from the Instagram folks. I know that wasn't you giving the talk, but at PyCon, so that was pretty interesting. But I think actually that work that you're talking about, especially with Lucas, really kind of opened a lot of people's eyes about Python typing, right? He gave a couple of PyCon talks, showed, real metrics of how much of the code base is typed, how much it's changed, like error detection, right? That kind of stuff. So let me ask you, do you feel like it would be different? Would it have gone different now if tools like TY and Firefly existed back then? Like, is Python typing different now than it was then?
Certainly, yes. I mean, the type system has gotten more complex over time, so it is both more expressive and more complex. And yeah, we have more type checkers available now.
Hold on. I think for some reason my audio just cut out. Can you all still hear me?
I can hear you.
Okay, yeah, it came back. I don't know. These AirPods. You know how AirPods switch? I got a text which made a noise on my iPad, and I think my sound switched to my iPad. Anyway, sorry about that. I do agree that it's more complicated, and I don't know how to feel about that. It is more expressive, but I feel like it's starting to get. I mean, we're not at C++ ATL like templates of templates of templates, but still, it's getting more serious. But I guess one of the really nice parts is that you can just take as much as you want of the complexity and you can just leave the rest, right? That's part of the magic of Python typing, is that it's a gradual typing system, right? That's a choice people get to make. It can be none, it can be quite a bit, and anywhere in between. So I guess that's probably one of the decisions. Let's talk about the typing council. So when did the typing council come along, and did the typing council exist to create all of these PEPs and make this happen, or was it afterwards? Like, what's the history of the typing council and its purpose, folks?
Yeah, it postdates most of the PEPs. So initially, the type system was created just through the regular PEP process, which means that something gets submitted, at first still to Guido as the BDFL, later to the steering council. But that meant that it's very hard to make changes to like this specification. Like anytime you want to change something about how the type system should work, we had to go through this PEP procedure, talk to the steering council, who are very busy people who deal with a lot of other aspects of the language other than typing. So Shantanu and I came up with this idea of creating a separate council to specifically in charge of typing that would maintain a specification where we can make small changes ourselves without having to go through this whole PEP process. And this way, when all the type checkers agree that something needs to go a certain way and it's not exactly what's in the PEPs, we can change it and have a place to record that, and people can refer to it, and new type checkers can also try to follow those decisions.
Very interesting. I didn't realize that it was was there to allow for small changes to be made to make that much easier. But of course that makes sense, because the PEP process it's pretty serious and drawn out, and we've seen even small language changes have quite passionate folks, I guess we should say. So yeah, very nice. Do you have any examples of the types of changes that y'all that have happened over the years that maybe were typing council only?
One was the specification for how overloads work, which is perhaps not really a small change, but one of the most complicated features in the type system really is the overload, where you can give multiple signatures for a function, and type checkers sort of select which one to use based on the arguments when the function is called. And when it was initially created, from what I recall, just wasn't really a specification. It's just like you use the signatures in a way that makes sense. And Eric Trout, who's currently on the council, came up with a pretty specific procedure for exactly how overload should work to make it so that type checkers have both so that users can understand how it works and so that type checkers can have something to work towards to make sure that they will implement overloads in the same way.
Yeah.
Maybe a smaller example that is an example of something that would have been too small for a PEP and hard to accomplish before the typing council existed. And this was actually a change that I pushed through before before I was on the typing council, but the typing council approved it, was a clarification around the interpretation of data class fields. If a final annotation is applied to a data class field, does that mean, so if you apply a final annotation to a regular class attribute, since it can't be changed, that implies that it's a class variable. And there was a question of if that should be the interpretation with the data class or not. So we discussed that and made a clarification to the spec.
Okay. Interesting. I've never really thought about final being applied to a class field, but I've always used them sort of just for constants. But maybe people out there don't know, like typing dot final bracket type, right? That's kind of the way you can do constants in Python, right?
Constant for the type checker. Nothing in the runtime will stop you from editing it, but
Not there. I have some examples coming up, and I'm interested to hear your thoughts on them. But for sure, there is this tension, right? I mean, I think that's probably worth touching on as well. Is this is a tension for Python in general? Is you can write all the types you want, and then when you run your code, it just doesn't care. There's a few instances, Pydantic, Fast API, a few others, but generally speaking, it's there for the editors and the type checkers and the linters, and not for runtime, right?
yeah, that's right. There's many exceptions to that. There's a project like MyPyC, which comes with MyPy that use those types to compile your code into more efficient machine code. Maybe there's going to be more projects like that in the future. I don't know. But yes, in general, it's separate from the runtime. Sort of a similar model to TypeScript, where TypeScript gets compiled into JavaScript and types just go away. Here we don't do a compilation step, but still the same idea of the types just not influencing the runtime.
Although we do make them available for introspection via
Yes.
done annotations attributes, which is what has enabled the projects like Pydantic and other sort of runtime checkers to make use of type annotations at runtime also.
Yeah, I don't know if the typing council is around for this, but there was a proposal. I don't remember the exact details, but something to the effect of for type checking, not actually doing some of the full imports or something along those lines, right? Where the runtime behavior would have made it hard for tools like Pydantic and others to get that. And there was some kind of compromise, right? I don't remember the
Under
details.
annotation.
Anyone does?
Future import.
Yes, I
Yeah.
think so.
Yeah, it's like PEP 563 and 649 or something.
And 749.
Yeah. Yeah, what happened was that there was going to be a change. That's what the from future import annotations import does. That changes all annotations into raw strings. So the default behavior before recently was that annotations that are regular code, if you write deff return to int and you import the module, it just looks up the name int and puts that in an annotations dictionary. Which makes introspection easy, but it had some costs on performance because memory usage sometimes was high, and also made things harder to use sometimes because if you use a name that's not defined yet at runtime, you get an error. That often comes up if you have like a class that has a reference in an annotation to the class itself, or circular dependency between classes.
Right, the circular imports, because you want to say this class is created by that thing and it returns one, but like, somehow you've got to import the other one, and that's such a hassle. Even out in the audience we have Tom says circular imports. Oh yeah, for sure. What about lazy imports? Like that just recently got accepted and will be in 3.15, which I'm super excited about because I think it'll make app startup a lot faster for many use cases. But does that have knock-on effects for typing?
Not that directly, because I think for a type checker, lazy imports mostly just look like regular imports. I guess I should maybe leave that to the people who are actually working on type checkers that being written right now. Yeah.
Yeah, Rebecca, do you see this making any difference for you? Lazy imports?
Yeah. To be honest, it's not something we've looked at too carefully yet. 315 it seems a little far in the future, but I don't think it's likely to make a huge difference.
Carl?
Yeah, I've thought about it briefly, and I think that I think the type checkers really won't need to care. Maybe there will be some edge cases that'll come up that I haven't thought of, but it shouldn't be a big deal.
Yeah, that's what I thought as well. The one variation that I can certainly see is if you have if you have something specified in a type, like say for a field of a class or a Pydantic model or something, that would otherwise not trigger the lazy import to become imported, would potentially having types specify cause more importing to happen sooner in the runtime.
Yeah, there's actually an issue related to this that I think we may need to resolve before 3.15, but I don't know how yet. In data classes, if you have if you use a type in a data class annotation that's lazily imported, actually creating the data class will delazify that import. It will try to resolve the import and actually make it not lazy. This is because data classes doesn't really need to look at all of the annotations in your class, but it looks at them enough to trigger reification of the import. I shared this with some of the people on the lazy imports team, but we haven't yet come up with a good way around it. I think this might end up being a bit of a food gun, so I feel like we should ideally find a workaround, but I don't know what it would be yet.
Yeah, I don't know that it's wrong that it converts it to an eager import, which it needs to know what it is potentially, all right?
Oh, it actually doesn't. Data classes just need to know whether it's a class var or not. And I think that's pretty much all. I guess there's an init var also, but it doesn't really need to know anything else. So in theory, it should be possible to just say like, hey, this is not class var, so don't bother importing it.
Interesting. Okay, so that's for data classes, but like say if I specify a parameter type on a function.
Yeah, then it should be fine. I guess, again, unless something is invalidating those annotations. So if you have something like a decorator that looks at the annotations in your function, it might reify those imports.
Okay, interesting.
There is one other potentially interesting thing for type checkers. It's already difficult for type checkers to figure out when like a submodule should be considered to be an attribute of the parent module, because the way this happens in Python is that any import of a submodule anywhere will attach that submodule as an attribute on the parent module. But that at runtime, that could literally happen anywhere. It could happen in totally unrelated code outside of the module, and a type checker probably won't be able to see that. So type checkers already have sort of complex sets of rules around where they look for these submodule imports and when they consider a submodule import to be reliably happening enough that the type checker should consider this submodule to exist as an attribute. And lazy imports may make that even. We'll add one more wrinkle to those sets of heuristics, in that we'll have to decide if you have a lazy import of a submodule and you're under a init.py, it's lazy. So should the type checker consider that submodule to be imported or not be imported? I think it'll be another case where there's no clear right answer, and we'll just have to make a decision one way or the other.
Right. Yeah, there's some variations across type checkers, which we'll get to later. I think, though, before we move off this, there's actually, off introducing the typing council, I think we should point out that there's two other folks who couldn't be here who are also on the typing council, Eric Trout and Yuka Letosalo. Sorry, Yuka. But want to make sure that we point out there's actually 5 people, not just the 3 of you, right? How do you get on the council? Is there an election? Do you just apply?
Vacancies are filled by the members themselves. So when somebody declares the intention to leave the council, we basically ask for people who are interested and then make a selection. Generally, we try to get people who have experience in the type system. We try to get a good cross-representation of people working on different type checkers. So we have Carl and Rebecca here who work on 2 type checkers, TY and Firefly. Yuka works on MyPy, Eric Chart works on Pyrites, which are 2 of the most widely used type checkers. Yeah, so we try to get wide representation of people working on those parts of the ecosystem.
Yeah, that's really cool that it has got a bias towards finding people actually doing the work. So let's talk about the specification project at typing.python.org. What is this here?
I mean, I can
Yeah, go for it.
talk a bit about it. I guess it's a specification for how the type system is to work. The way it started was that you basically took all the typing peps and like stapled them together, right, to make like one long doc. And since then,
Right.
we've been iterating on it, filling in parts that were missing, like overload evaluation and making other changes as well.
Yeah, it's tricky, right? Because traditionally the typing system is kind of defined across a series of peps, right? And so what is the document that tells you how it works, right?
Yeah, that made it hard because often those peps build on top of each other. So then in the extreme, you might see like one thing in one pep, and then there's another pep that adds an aspect of it, another one that adds another aspect. And overall it makes it very hard to follow. One of the things I did recently was rewrite the typed dict spec. Typed dict is a feature of the Python type system that has been added to a lot from one pep to another. And I ended up rewriting the whole thing to basically put all those features together in a coherent whole rather than just having them all copy-pasted one after the other.
Very nice. Okay, so if somebody really wants a good understanding of the Python typing system, they go to typing.python.org. One thing I think maybe is worth touching on, it's just kind of out of the blue a bit, but I think it's a really interesting aspect of the Python typing system is the, what's it called, the numerical tower or the number tower, where it's like, if I have a number, I could specify it as an int, or I could specify it as a float, and those kinds of things. But do you really need to say it's a int pipe float or a union of int and float if it could be either, right? And the what is that called? It's the numerical tower, right? I think
There are many there are different towers too. In Python, there's also this thing called a numbers module that's that you have there. That's just basically ignored by the type system.
Yeah.
I think it's, I don't know. It's been useful for some people. I feel like in general that module just hasn't worked out very well as being very useful.
Yeah, I think for some reason I'm failing to find this in real time, but I think the interesting aspect is that that you can say it's a float, and that's basically equivalent to union of integer and float, and so on, right? I think the typing numbers in Python is pretty interesting.
I think every type checker has a different interpretation of what a float annotation actually means.
Yeah.
Oh, really? Okay.
It's an area of some lack of clarity in the spec.
Yeah, and a lot of contentiousness.
If we could go back in time, I would, like, knowing what I know now, I'd probably advocate for things being done differently, because like at the beginning, like there were multiple things like with similar flavor. Like there was also one where you could give a parameter a non-none annotation and default it to none for convenience. And we've largely like moved away from stuff like that in favor of explicitness.
Yeah, what the current spec says is that basically if you have a function that takes a float, you're also allowed to pass an int. But that's not really enough. It doesn't tell you how these things work in all cases. And we've had some attempts to try to come up with a way to specify that special case in a way that makes more sense. At least makes more sense to me. It's been
Yeah.
very contentious. People have very strong opinions about this. Yeah.
It is a little weird, isn't it? And
It's
a
quite
little,
weird.
I guess non-obvious is what I'd like to say, really, honestly. So I'd like to get the official council's thoughts on this. When is typing too much typing, right? I made the joke about C++, ATL. If you've ever worked with that, it's like a parameter, a template class where templated classes are part of the concrete type of the template. Like, it's just off the hook. There's certainly places where typing can be too much, and a lot of the purity of Python, or the readability of Python, is the fact that it's got so few symbols. And so adding types adds context, but it also takes away, makes it a little harder to read. When is too much typing? When do you recommend typing? Maybe Rebecca, I'll let you go first, but like, what are your thoughts on this sort of like how much typing should I use in Python?
Okay, I'll give you what is sort of my official stance, which is that if you want your type checker to work well, you should type annotate your API boundaries. So like parameters and returns and public functions, public class attributes, things like that. And like even things that seem trivial, like, oh, this function returns none, better to annotate it because someone else might be depending on your library and consuming that type information. I will say personally, what I tend to do is like I annotate things that I think are non-trivial because I want to see that as documentation. And if something like, a function that does return none, to be honest, I will probably forget to annotate it half the time because I'll be like, I honestly don't need to see it. So.
Yeah, one of the interesting features of the Firefly VS Code extension, that's the only one I can speak of at the moment. And Carl, you got to tell me if the TY one does this as well, is it will sort of overlay its belief of what types are. Like if you say X equals a function return value and it knows what the function returns, it'll have a gray like :int if it returned an int or something. So you can kind of read the code and see what the types are without actually putting it into the text of the code. It's only within the editor. Does TY do something like that, Carl?
Yes, we also have inlay type-ins.
Yeah, inlay type-ins, that's what it's called. So yeah, I don't know. That also brings an interesting challenge, not a challenge, like a wrinkle to the recommendation of should I put types on like the return value because I want to know that's a list of user, not a list of user IDs or whatever, for example, like a list of UUID. But if it's going to show up anyway in the editor, maybe I don't have to write that, right? And so that becomes sort of somewhere where you could debate again, I think. However, I do 100% agree with you, Rebecca, that put it on your API boundaries. If this is the place that people get into some part of your code and they don't know or want to know about the inside of it, having types there is really helpful, both for editors, for type checkers, and just for reading code, and even for AI, which is a crazy world. Yeah. Carl, what are your thoughts here? How much typing is too much typing? Or what's the guidelines here?
Oh, I think I agree with Rebecca's answer. I mean that one place you definitely want to have explicit type annotations is at API boundaries, the public API of a library, etc. In terms of what's too much typing, I mean there's certainly patterns that have historically been used in Python that we still can't express well in the type system, or that require extremely complex type annotations to express well. And I think there it's becomes a judgment call. If it's like a core widely used API, you may get a lot of benefit from some very complex and verbose annotations. And so then it's worth sort of going through that pain and the pain of adding them and of reading them in order to get that additional typing coverage everywhere you use that API. If it's much less frequently used code that's highly dynamic, maybe it's not worth it in that case. I think there's a lot of judgment calls here.
What about like one-off scripts? I'm going to write this thing to just move this data from here to there, and once it's moved, I don't need it again. We're done with that old system. We're going to the new one. Maybe less typing.
Yeah, I think it's up to what's useful for you. Often I feel like one-off scripts are not really one-off. Like maybe you want to move some similar data later, and then it's useful if you can understand your code again, if you want to read what you did.
You thought you didn't need it again, and all of a sudden it's 6 months old. You don't understand it, and the types would help a lot, right?
Yeah.
Yeah. Jelle, what's your advice?
Yeah, I think what Carl and Rebecca said makes sense to me too. I think types have advantages in terms of documenting human readers what is going on, and in terms of catching mistakes that otherwise would not be caught until runtime, perhaps. They have costs in maybe making your code harder to read if there's too much going on. So add types as long as those benefits outweigh the costs.
Yeah. I mean, do you recommend to anyone that they just 100% go full like C++, C# on it and just type it every single thing? Is there an advantage like for static type checkers, like MyPy type stuff you can run across and get that? I mean, you could do that with Firefly or TY and the CLI as well, but, thinking more MyPy is like kind of being real strict on some of that stuff.
Personally, I do tend to annotate almost all like function parameters and if class attributes if I make a class. Sometimes it's not as necessary, like you don't really need to annotate your tests perhaps, or you don't need to annotate internal functions as much. But for my own coding, I usually find it helpful to do that.
Yeah.
But sometimes I see people annotating even local variables where it's very obvious to type checkers what the type is, and they can just infer it reliably, and then it really just adds noise, and you shouldn't do it.
Yeah, exactly. If you've got a function that's annotated with a return value, and you say x equals the function call, then the type checkers can infer that, and you're just causing extra noise, I guess. So suppose you all want to change something. What's the process of actually going through and making some changes?
Yeah, there's mostly sort of two levels of this. Well, maybe there's even three levels. The first one is if it's something that's so small that's just like a wording clarification or something, we just make a PR to the repo, and a few of us look at it and we change it. The second level is when it's sort of a smaller change that doesn't really introduce a new feature, and then we make a PR to the typing spec repo, and we formally have all of us sign off on it. That would have happened like with what Carl mentioned earlier of the final change in data classes.
Nice.
Yeah.
Just had to merge this one. Yeah. Add Carl.
Yeah. But,
I love it.
yeah, I guess this repo itself doesn't have anything. It's the Python typing repo where the decisions are made. The typing council just has like some small documentation.
Maybe this one.
Yeah. And then the third level is PEPs, like really big new changes. You can still write a PEP, and then we make a recommendation, and the steering council makes a decision eventually.
Okay. So if I wanted to suggest something, I could come up here and I could open up an issue, maybe start a conversation on typing, Python/typing.
And you can make a pull request to change the spec.
Okay. And so the pull request would not be to change the code, like how Python maybe interprets code that has this new thing, but to suggest that the spec has it, which then would start a process that ultimately might make CPython understand it, right?
Well, CPython itself probably doesn't do anything with it. I guess most of the things that go directly here are changes to how to interpret things that are already in CPython. If it's adding something new, it will usually need to go through a PEP, except if it's something very small.
Yeah, I guess, maybe let's talk about that for a minute. We got two representatives here of the newer breed of tools. Like, what's the story for inconsistencies across interpretations of the spec. I know that there's slight variations. I've also, not putting either of you on the spotlight, but like using, say, PyCharm and like writing code, so its type checker is happy, and then using something like Pywrite, and so it has a real different interpretation of what you should let slide and what you shouldn't. I feel like Pywrite is much more focused on like enforcing the nullability or the lack thereof, and it warns of inconsistencies there where PyCharm doesn't seem to care as much. And I don't know which one I like better, but I know they're different. And if I write code in one, then I open the other, I'm like, why is it upset? It seemed like it was fine.
Yeah,
How do you all navigate this? Yeah.
I think one thing useful to say about the spec there is that the spec covers a lot of things. In particular, it tends to cover sort of the details of more advanced type system features, but there's a lot of very fundamental stuff about how a type checker works in terms of how it does inference and how it does type narrowing, and even in some cases, like you mentioned, what it chooses to emit errors on that isn't really covered by the spec. Partly maybe because we haven't gotten to it, and also partly intentionally, in that there may be room in some of those cases for different type checkers to work differently if they're serving different needs. Like if PyCharm is primarily concerned about being a useful kind of IDE and providing go-to definition and that sort of thing, maybe emitting lots of warnings or errors and all kinds of things where your code might be doing something wrong isn't as high a priority, and another type checker might have a different priority.
One thing do want to mention is that it may not seem like it, but things are already much better than they used to be. Like previously, I worked on a different type checker called PyType, and at that time it was, sort of the Wild West. Like we want to know how other type checkers like do something. Well, like open up the MyPy playground, open up the Pywrite playground, see what tells you. Now we at least have spec and conformance tests.
Yeah, that's really cool. How much would you say that your two type checkers maybe bring in MyPy as well? Like how much do they agree versus disagree? Like you only see the differences. You don't see in which ways that they are the same as a consumer of them so much, right? You're like, why is this one squiggly when it wasn't squiggly before? But how similar or different are they?
I don't know how we would quantify that. I think there's a lot that is the same just because it's based on how Python actually works.
Yeah, sure.
We're both trying to model the same language. And then there's certainly also plenty of differences or things that we handle differently. So I don't know, Rebecca, do you have a better way to quantify that?
Yeah.
I agree. It's hard to quantify. I suppose talk a bit abstractly about various like type checkers philosophies. Like with Firefly, like we really try to do a lot of type inference. So in that's way in which like we intentionally diverge a bit from MyPy. But like other than like that deliberate decision, if we see ways in which we are like accidentally different, we do try to fix that, because otherwise people would have a hard time like running multiple type checkers or migrating.
Yeah, differences obviously cause pain for users who are using multiple type checkers or writing libraries that need to support multiple type checkers. So like Rebecca said, it's like if we are different from other type checkers, we want to be sure that there's a good reason for that difference. Oh, lost your audio, Michael.
Yeah.
Right. Sorry. The difference should be because of philosophical choice, not just you happen to have chosen slightly differently, right? Yeah, and it's not just people who run different type checkers. Like you pointed out, Carl, a lot of times it is if I have a library and then different people want to consume that library, then their type checker may or may not warn them about how my library declares its types and so on. I'll give you a real quick example. I can't remember which one it was. I have 3 or 4 different open source libraries that I've created that somehow work with creating, basically passing data to templates in web apps, right? So one is like, I want to use the Chameleon web template framework, but with Fast API or with Flask, and there's some other variations like partials and so on. I can't remember which one, but it doesn't really matter. One of them decorated a Flask. I think it was a Flask, especially makes it irrelevant, a Flask endpoint. And Pyrite was really upset. Like the error message filled the entire page of how it was inconsistent with what it expected for the definition of the Flask view method. I'm like, no one is going to call this. Like, what does it even matter what this type is? Like, it still runs fine. The runtime is fine. It's no problem with this decorator. It worked fine. But something about the way that the Flask at get returned the type versus what my thing returned varied in like a really slight way. I didn't care, but somebody was using some editor that used Pyrite, and they're like, you have to help fix this. I can't take all these warnings. They're huge and they're everywhere. Like, okay, I'll go fix it. Right. And I went and I put way more effort than was justified into a function type that no one ever calls, just to make the errors on some type checker I didn't use go away, right? And that's the kind of thing where it becomes just a headache. I don't know. I wish I remember. I probably got that written down in an issue somebody filed, but it was a gnarly error. Or if you're working on an open source project, you can't make everybody use the same editor that wants to contribute on a big project. And so you might run into this variation as well. So there's a lot of cases.
Yeah, it can be really difficult to make these decisions about what sorts of errors people want their type checker to catch, or what's too pedantic. Because, you want your type checker to catch non-obvious errors, not just the obvious ones that you probably would have seen by looking at the code yourself. But then there will be cases where somebody says, well, I don't care, that's too pedantic. And it is difficult to make everyone happy.
Yeah, exactly. When I was seeing it, I'm like, well, who decides what the right signature of a Flask view endpoint should be? Like, if the framework can call it, it should be okay. There's not, just because it had a decorator before, that doesn't mean that's the official structure. But anyway, I do think one of the bigger philosophical differences has to do around this concept of nullability. Like, do you guys call it nullability or none-ability? Like, I don't know, nullability comes from the other languages, and by that I mean I can specify that I have an integer, and in the Python type system, it cannot be set to none, even though in the runtime it can. It has to be a concrete int type unless you make it a optional int or an int pipe none or one of those type things, right? And how strong that gets enforced seems to be one of the biggest difference of opinions that I've seen around. Like, how do you all think about that?
That's interesting to me, that's your experience, because my experience has been that that's actually an area where everyone seems to agree, as far as I can tell, that these are is an important source of bugs and it's better to catch them. So I think all of the type checkers, maybe you said PyCharm doesn't.
I don't think PyCharm does that. I'm pretty sure it doesn't, because I agree that it's an important thing to check, but it's also a point of a lot of friction. And by that, I mean, let's suppose I'm going to have a class that I need to create an instance of and then put values into. And I know once I put the values into it, let's say it has a user ID, I know for certain that that's going to be an integer, right? So I'd like to say user ID :int, because everywhere I use that object later, if it's a function that takes an int and I specify it as optional int, I will get a type check warning every single call site when I try to pass that. But I know from the semantics of the behavior that it's going to always be an int unless it's not initialized, right? And like in this short period where I want to create it. So I can't set the type to int. I have to set to optional int until I've loaded it. But there's like this, I don't know, that's the part where I see a lot of it show up is inconsistencies and then warnings all over the place. So I'm like, well, but that the function is actually checking if it's none, and it'll return null, none, or something like that. So I don't know. I totally agree with you. It's just somewhere I've seen the most inconsistencies across maybe PyCharm versus others. But,
MyPy also has a legacy mode for not checking none things called non-strict optional. We are trying to get rid of that from MyPy because strict optional, like being strict about it, is the more sensible thing to do.
sure.
But it's possible that you've seen that too. Yeah, I agree.
Yeah.
So what you mentioned is maybe sort of a special case of the case where you pass something to a class and there's initialization that changes the types. Doesn't necessarily have to deal with none. It could also just be like the attribute doesn't exist at all beforehand or something.
Yeah.
Yeah, we don't have a good solution for that. Maybe there's room for something to support that use case better. I don't know what it would look like.
I mean, I think
I don't know.
in some
Go ahead,
cases,
Carl.
there's ways you can, these things can sometimes nudge you towards a different design that is actually safer and will avoid errors. Like in the kind of case you're talking about, is it actually necessary that an uninitialized object and an initialized one are represented by the same type? Or is there a way to adjust the API so that those are actually different types? Then you solve the problem and your code is safer. So
Yeah, no, I totally hear you. I'm thinking like you submit a web form, and before you parse it, you've got to create the instance to set the values. And I don't know. It's not worth diving into, but I do find this differentiation between like the strict enforcement of none versus not none. I think it's powerful, and I do think you all are right that it does catch a lot of errors. It's just a difference, and it's just an interesting choice. But I didn't get a concrete answer from the official council. Nullable or nunnable? What is it?
I feel like we just don't really even talk about it as a term mostly. None is special in the type system in like how you represent it, but it's not really special in other ways.
Yeah. So you don't have a term for int pipe none?
Int or none.
Well, historically the term was optional, although I think that term has problems, and we're sort of moving away from it because specifically one problem is that optional can mean you don't have to pass it in, like I say, as a function parameter.
Right,
So
and that's not the intention. Yeah, it has two total different meanings there. Interesting. All right, let's talk a little bit about typeshed. I think typeshed is pretty interesting. Maybe people don't know too much about it. So I'm sure you all are familiar with this project that you can basically add type information that the libraries didn't bother to include for you, right? What are thoughts on typeshed? How much do you all lean on this to sort of round out missing types?
I mean, there are two parts to typeshed, right? There's the standard library type stubs, which I think are invaluable. Like all the type checkers use those. And I mean, will the standard library itself ever have inline types? Who knows? This might be around forever. And then there are also the third-party stubs. And I think that's what you're describing. There are libraries that, for whatever reason, don't ship with stubs themselves. Right. Those are in typeshed. And I think it's been like for a while, there's sort of been a question of like what we want to do with like typeshed's third-party stubs, right? Because like ideally, like libraries would ship with their own types, but there are various obstacles to that.
The older the obstacles that I know of used to be like, we want this to run on Python 2 and Python 3, or we want it to run on Python 3.3 still. But it's been a long time since any non-type supporting version of Python was a real, a supported type of thing, right? I mean, even 3.9 became deprecated. So on one hand, I feel like they could be merged in, but there's also a lot of other areas that are maybe they're not common, right? Like other other libraries like, I don't know, just pick some old, let's say Pyramid. I don't think the Pyramid web framework really ever got types added to it. Right? Somebody could go and create a type shed stub or a types underscore pyramid you could pip install, and then we'll add the types, right? I certainly see it being really valuable for third-party things that are just not going to get the type attention they need. Yellow, what do you think?
Yeah, I think TypeShed is great. I've spent a lot of time on improving it. As Rebecca said, especially with a standard library, it's irreplaceable. For third-party libraries, I think it's become less needed over time. It used to be that very few third-party libraries had any types. Now that's obviously changed. A lot of libraries ship their own types. But still, there are quite a few types of libraries left where there aren't inline types, and TypeShed can provide useful types. I think TypeShed also provides a service because it has a really great framework for testing these types. We have tools like StubTest and various type checkers that help to make sure these types are good and meet a high standard. So yeah, I think they're still useful for many libraries.
Yeah, I was just looking at the types Flask, and I guess it must be gone because now Flask must have it internally. So it's kind of an interim sort of thing. That's pretty cool.
Yeah, in general, TypeShed has a policy that we remove the stubs from TypeShed if they are in the library itself.
Yeah. Yeah, very cool. Okay. I find these super valuable because if there's a library I want to work with and it just doesn't have types for whatever reason, you can install stuff from here and all of a sudden your editor's way happier. I mean, I know you all agreed on like the API boundaries, and I did as well. It's like that's one of the really cool things. The other thing that really makes me excited about types is if I hit dot in my editor, I get a meaningful list of real information about what I'm working on. And so adding these types of things are pretty interesting. I want to ask you all about sort of these rogue tools that do stuff with Python typing that maybe y'all didn't intend. Like we all mentioned Pydantic. We've got Typer and Fast API. But even a little farther out there is Bear Type. Are you familiar with Bear Type?
Yep.
Yeah, Bear Type's interesting. You can import. They have fun. They have fun with their import names and stuff. But basically, you can put either a decorator onto some sort of call site or something, or you can just do it to an entire package or entire modules rather. So just from beartype.claw import beartype this, and then it actually turns into runtime type checks. Good idea, bad idea, interesting. What do you all think? So unPythonic, you won't even open the web page?
I think people should feel free to write whatever code helps them make like better software. I haven't really used BearType much myself, but clearly it's useful for some people. And I think in general, in designing a type system, we should try to accommodate all users who do useful things with the type system. And that includes things like Pydantic or BearType.
Yeah, it's pretty fast. It's not as big of a hit as you would imagine. Let me see, where did they? Somewhere they had a really fun saying in here, but here we go. BearType brings Rust, C++ inspired zero-cost abstractions into the lawless world of dynamically typed Python by enforcing type safety at the granular level of functions and methods against type hints standardized by the Python community. And order one, non-amortized, worst case time with negligible constant factors. Like, how about that? No, it's a pretty neat library, and it's pretty fast. I've never used it in production. Having type hints and squigglies in the editors or in the linters has always been enough for me. But I can see using this if it's really critical and you're having issues. Maybe you want to catch some runtime errors. I don't know. not quite an endorsement, but it sure is like that's different type of thing.
I definitely think that the extent to which type checkers may have a different understanding of your code from what happens at runtime, and there isn't anything built in to catch that is sometimes a pain point. And so the desire to have your type annotations, to find out at runtime if your type annotations are telling you a lie, it makes a lot of sense why people would like that. I mean, something they've been used to from other languages where the type checker is built into the compiler.
Right. You get like a runtime typecast, like we kind of get that if you try to parse a thing, like put the int param around a string, and it's not really parsable as an int. But for like real type information, I think personally I would use this as like, I might apply type checking to a module for debugging and development for a minute and just see what happens and then turn it back off. I don't know that I'd just ship production code that way. But anyway, all right, I got a couple more questions. We're getting shorter on time here. What was one of the harder questions that you all, or harder decisions you all had to address on the council?
I think the most contentious one was PEP 724, if I remember the number correctly.
Okay.
Which was around a feature called type guards, which is around user-defined type narrowing functions. We initially defined that in a way that later was found to be somewhat problematic, and we basically came up with a better set of proposed semantics that maybe we should have done in the first time around. And what this PEP proposed, and as you can see I sponsored it, is that we basically changed the meaning of the existing type guards under certain conditions. Which,
What is a type guard?
A type guard is a function, like there's a good example there, the isIterable. It's a function that tells you how to narrow something. So in this example, there's an isIterable type guard, which narrows an object to an iterable of anything. And then inside the func there, you can see if isIterable val, it knows that it's an iterable. And in this case, I guess it just narrows exactly to iterable any. That's one of the ways that type guards works.
I see. And the type that returns kind of communicates to the type system like that this function ensures that the thing that came in as an arbitrary object in fact is one of these.
Yeah.
Okay, interesting. Yeah, so that was a tricky one, huh?
Yeah.
Any other standout, Rebecca or Carl?
Well, the current discussion around what is the meaning of a float annotation, still unresolved, contentious topic.
Okay, gotcha.
I mean, this on PEP 724 is also what came to my mind immediately as well, because this was challenging discussion because, there were very conflicting considerations at play. It's like, what semantics did we want in the long term, and what did we want the type system to look like, say like 10 years from now versus backwards compatibility, and what the migration story would look like. It was quite tricky.
Yeah, I guess that's something you all always have to be cognizant of, is like every change, even if it's an improvement, has to justify the fact that now you have challenges with the version history over time. I'm thinking like dict of string comma int with the capital or lowercase d. I've got people, I did a YouTube video showing something with the lowercase version because I was using something super modern like Python 3.11. And I got a message like, hey, Michael, you don't know how to write Python. Your code is broken. This code that you wrote just doesn't even run. I don't know how this is. I'm like, what version of Python are you using? 3.8? Nope, you can't use 3.8 for that. You're going to need to get a newer one. You know what I mean? But like those are complexities that get added to Python because of that. Now you've got two ways to specify what a dict is. There's a preferred new way, but there's still the old way. And it sort of piles up. So,
and it's very hard to ever actually get rid of the old way, even if there's no good reason to use it anymore.
Exactly. Once it's there, it's written in ink pretty much, right? Like we have 5 or 6 different ways to format strings. Maybe with T strings it's 6 now. They're all going to still be there, right? So every change, every decision you make is not just a matter of is it the right decision, right? It's the is it worth it? I'm sure. Yeah. I don't know. How do you all balance that? Like that's tricky.
With things like the dict change, at least we sort of know we're moving towards a better state, and there's two things, but they mean exactly the same thing, so the confusion is not as bad. The problem with typecard was that we were going to change how some existing thing worked, like what it meant, and I think there are good reasons that maybe that was the right thing to do, but it would also have been pretty confusing for people if their existing types suddenly started meaning something completely different.
Yeah, absolutely. Hence float. Okay. All right, let's do what's coming next. Like 315, 316, do you all have things that are in the works that you think are going to come or debates that are brewing?
I think for 315, there's a type dict feature coming, extra items. You can already use it in typing extensions if you want to use it, but it will be in CPython as of 3.15. It's likely we'll have a small thing I added called disjoint basis, which is very technical, but helps type narrowing in some cases. Yeah, I think those are the things that are likely to make it. We can only speculate about what else people can propose. We're sort of bound by what people actually write up as PEPs. We have to wait for people to write the PEPs before we can approve them.
I think there's PEP 747 for typeform, which I think is not. I think we recommended its acceptance, but I don't think the steering council accepted it yet, or has it been accepted formally?
I think that's right. I think that's on their plate. Yeah, yeah. So that's also pretty likely to make it into 3.15.
Okay.
So this is one example of a case that will be pretty useful to people working with type annotations at runtime, because it'll allow you to. It's sort of a meta thing where you can have a type annotation that describes another type annotation. So that's useful if you're writing code that works with type annotations.
Sure. Okay. Make the Pydantics of the world very happy.
I am actually pretty excited about type form because, I feel like there's a gap and we can express in the type system.
Yeah.
Plug that in, we good.
And there are cases in the existing type system, like for instance, the cast function and some other cases where something takes any type expression as an argument. We actually don't have a good way to annotate that today, and this will provide a nice way to express that.
Yeah. Okay, cool. Let me pull up one thing really quick. Quick shout out to Will McGugan here. He just released his Toad project, which is the new takes textual and rich and all that kind of stuff and applies it to like, what if we had a better Claude Code type of experience, which is pretty interesting. So the reason I'm bringing this up is, final question. What about, do you all even worry about the role of like how types interact with AI and agentic coding tools? I know that if you have some code that has types on it and you give it to an AI, it's got a better chance of understanding what's happening than if you give it purely untyped code and say, tell me about this, right? It doesn't even know necessarily what's being passed to it. But is that anything you'll think about, or what are your thoughts on this?
Certainly think about it some. I mean, I think overall my feeling is that these coding agents seem to do better the more kind of the tighter feedback loops you can give them to work with. And so typing is another useful source of feedback where you can say, add type annotations and make sure the type checker passes, and seems so it still seems pretty useful in that world.
Yeah, you can easily write rules that say when you are done on anything I've asked you to do, always run TY or always run Firefly and make sure that there's no new errors, or at least, or ideally 0 errors, right? But nothing has been introduced. Yeah, pretty interesting. You other folks? Rebecca, Jelle?
Yeah, I guess in general, I think typing will remain useful for AI. We are probably rapidly moving to a world where a large proportion of all code is written by AI. And
not everybody likes that opinion.
not everybody likes that. I guess maybe my current line of work makes me think that's more likely to happen.
You know what, though? I mean, it's also, you don't have to like the fact it's going to be night soon, but it's going to be night. You know, I mean, like, I just think there's so much momentum on this, at least in the next 5 years or something, that it's going to be really, it's a truth of how many people are writing code, regardless of whether individuals want to write code that way. You know what I mean? So I think it's a consideration.
Yeah.
Yeah, I forgot that you worked at OpenAI, so of course. And I should pull up a Codex example or something, shouldn't I?
Yeah, Codex is great. Use it.
No, but I mean, do you have any further insight into like the role of types in coding agents? I know that's not exactly what you work on, right?
It's not too much really. I think, as Carl said, types can also be helpful for AI to understand code better and to get a better feedback loop. I feel like the better we make AI, the more it is like humans. And if typing makes humans better at writing, understanding this code, it'll probably also make AI better at it.
Yeah, it's the locality of information. You can read the function and know everything you need to know about what's going into it without bouncing around and trying to understand blocks of code and like what might have been created that's getting impacted. It's good for humans and also good for AI. You're right. Rebecca.
I mean, I guess I don't have much new to add. I'll say I am maybe a little more skeptical than most of my coworkers about the quality of AI generated code, but that also means I think I am particularly gung-ho about, like get AIs to use types, type checkers, keep the guardrails there. I think that'll be very important.
If it's going to make a mistake, don't let it at least like make the type system become disconnected and not working. Like it has to keep the types hanging together as a minimum bar, right? And you can easily set that up as an automation. Yeah, interesting to think of it as guardrails rather than an accelerant. But yeah, 100% it is. All right, folks. I think that's it for all the time that we have. Thank you for being here. Final thoughts before we go. Carl, I'll let you go first. Final thoughts for people out there interested in Python typing.
Yeah, well, first of all, thanks for having us on the podcast. Really appreciate it. And thoughts for people out there. I guess if you have ideas of how Python typing could be improved, discuss.python.org is a good place to bring up ideas and discuss them with the typing community and see what positive changes we can make.
Awesome.
Rebecca.
Yeah, I mean, first, thank you, Michael. This is a lot of fun. Last thoughts. So, like look at the typing council and sometimes think, like the PEP has like governance in its name, but I wouldn't say we're really a governing body or anything. It's like people who are using the type system, like users, they're the ones who come up with, like all the best ideas, propose them, discuss them. And we're just here to sort of be like, hey, like we have some background in like how type checkers work and maybe some of the history, and we can provide input. But I always encourage people, if there's a change you want to see in the type system, like propose it yourself. It's a very friendly and open community.
Yeah, now people who have listened know a little bit more about how to do so. Awesome. Thanks. Jelle, final word.
Yeah, also, again, thank you for having me here. It's been great talking to all of you. I guess what I want to say is similar to what Carl and Rebecca just said. If you want to something change in the type system, I'd really encourage you to sign up for discuss.python.org, make a proposal, go through the process. It can be somewhat daunting, perhaps, especially if you have to write a PEP, but it is doable. There are several recent typing PEPs have just been community members who saw something they wanted to improve, proposed a PEP, and saw it to completion. If there's something you want to see in the type system, then you can do it too.
Okay, awesome. Well, thank you all for keeping Python typing going strong. Really appreciate your time on the show. See you all later. Bye.